This example is a second type of problems with the existence of the elements of the sequence, the recursive sequence. So we have first the sequence is defined by u0 that belongs to R except for 1, and un plus 1 which is equal to 1 over un minus 1. So the function that defines this sequence is f of x equals 1 over x minus 1. First, we need to find the domain of the function, and then we will try to draw the variation table of the function so we can conclude what are the intervals that are mapped to themselves using this function. And then we have two choices of u0. First of all, we will set u0 equals 2, and we will try to find u1 and u2 and discuss the results. Second, we will give a value minus 1 to u0 and see what happens for the terms, the three first terms of the sequence. And then we need to prove that un will be less than 1, whatever was n superior or equal to 0. So let's start with the first question. Okay, so the function f of x equals 1 over x minus 1. And this is correct if and only if x different than 1. And this means that the domain is R except 1. Okay? Second question will be the domain of the will be the variation of the function. So we need to find the derivative of f, which is equal to minus 1 over x minus 1 squared. And this function is different than 0, plus it's strictly negative, whatever was x in the domain. So the domain of differentiability, it's equal to the domain of the function. Then we will draw the variation table of this function. So we have here minus 1, minus infinity, and then we have a problem with 1, and then plus infinity. We see now the sign of, we set the sign of f prime and the variation of f. The function, we said that the function is negative, whatever was the value of x. So the derivative is negative. And then we have the function is decreasing and then decreasing. It goes from 0 to minus infinity. You can find the limits. And then from plus infinity, we will go to 0. So we have here two things that we need to discuss. First of all, we need to see if the intervals that we are having here in this table are mapped to themselves or not using f. So we start with the first one, minus infinity and 1. So it's opened in 1. The function here, the image of this interval by f will be minus infinity 0. And of course, this interval is included in minus infinity 1. Okay? So we can conclude that the minus infinity 1 is mapped to itself. Okay? We now discuss the interval 1 plus infinity. So for 1 plus infinity, we have a problem with this interval because 1 plus infinity, the image of this interval by f will be 0 plus infinity. And 0 plus infinity is not included in 1 plus infinity. So this interval is not mapped to itself. Okay. So based on these results, we can have a discussion using the values of u0. So let's go to the first value or use the first value. It's about u0 that is equal to 2. So if u0 equals 2, the element u0 will belong to this interval, and it's not mapped to itself. So let's see the results. Okay, based on the results here, we have u0 equals 2. This means that u1 will be 1 over 2 minus 1 equals 1. And then we go to u2, and we will find that it's 1 minus 1. It's equal to 1 over 0. It's impossible. So whatever was n superior or equal to u2, un is not existing, donc doesn't exist. Okay? So this is the problem of an element, the first term, that is not in an interval that is mapped to itself. So the result here, we can conclude that because u0 belongs to a domain to 1 plus infinity, and 1 plus infinity is not mapped to itself, so that's why we will find this result. We go now to the second case, when we chose u0 equals minus 1. So here we have u1 equals, it will be 1 over minus 2, then u2 equals 1 over minus 1/2 minus 1, and it exists, etc. Okay, all the terms of the sequence exist. In fact, if we take a look at the variation table that we have here, we will see that if we consider u0 equals minus 1 in this interval that is mapped to itself, all the elements will be on the same interval, minus infinity 0. And this means what? This means that all the terms of the sequence will be less than 0, and especially less than 1. So let's write it here. So whatever was n superior than 0, if we take, of course, u0 equals minus 1, the un will belong, based on the variation table, will belong to minus infinity 0, which is included in minus infinity 1. So we can say directly that whatever was n superior or equal to 0, un is less than 0, strictly less than 1. This is correct. Okay? So here the function exists, and it has an upper bound, which is 0. We can consider 0, or we can consider 1. Okay? So the result with these two examples, that if we choose u0 belonging to an interval that is not mapped to itself, so we will face a problem with the existence of the elements of the sequence. And if u0 belongs to an interval that is mapped to itself, then we can discuss the convergence of the sequence, since the sequence exists already, and we can go further to the next steps with the bounds of the sequence, the monotonicity of the sequence, and then the convergence of the sequence.